Hi guys, your Friendtor Gopika is here and let's continue with the practice set 3.4. So this is the part 2 of the practice set. First 4 questions we discussed in the previous video. The next 4 we will discuss in this video. Okay, so without wasting time, let's get started. Okay, so this is the 5th question in your practice set. First, let's take the pointer and then start. Okay. So here we need to prove that any rectangle, okay, any rectangle in general is a cyclic quadrilateral. Okay, this is a very simple question. Just we need to notice, or we need to just remember the very simple property of a rectangle, and rest follows by cyclic quadrilateral theorem. Okay, so all the angles of a rectangle are right angles. Okay, this is a property you learned way back earlier. Okay, because you know that all angles of a rectangle are right angles, or all their measures are of all they measure 90 degree. Okay, so hence the pair of opposite angles are supplementary. Now here, if all the angles are of 90 degree measure, so the opposite angles, if you add measure of opposite angles, if you add 90 plus 90, you will get 180. The other pair also, if you add, you will get 180. So any pair of opposite angles you choose, you add it, you get the answer to be 180 degree. Hence the pair has to be supplementary. Now whenever you have angles, pair of opposite angles to be supplementary, by converse of cyclic quadrilateral theorem, you know that the quadrilateral is cyclic. So therefore, by converse of cyclic quadrilateral theorem, any rectangle is a cyclic quadrilateral. Okay, because you choose any rectangle, all its angles are right angles, so the pair of opposite angles will be supplementary. So they are cyclic quadrilaterals. Okay, simple observations, nothing more to prove. Okay, okay, so this is the 6th question. Here is the figure 3.59. Here if you see, YZ is height and XT is also height of triangles from two different vertex. So from vertex Y to Z, when base is WX, YZ is the altitude or the height. When WY is the base, XT is the height of the triangle or the altitude of the triangle. Okay, now both these altitudes is intersecting at point P. Okay, we need to prove that the quadrilateral WZPT, this small quadrilateral which is formed in the upper part of the diagram, that is WZPT, we need to prove that it is a cyclic quadrilateral. Okay, now to prove that it is cyclic, we need to prove that one pair of its opposite sides of its opposite angles are supplementary, and hence we can use the converse of cyclic quadrilateral theorem. That one pair we can very easily find. Here if you see this Z, now if they are altitudes, that means they are perpendicular to at the base. So here they have already mentioned that this Z, YZX, this is 90 degree. So the other side also it is 90 degree only. So this angle is 90 degree, WZP or PZW, and angle PTW is also 90 degrees since XT is perpendicular to WY. So these two angles are 90 degree and they are opposite angles. So in quadrilateral WZPT, angle PZW is 90 degree and angle P2W is 90 degree since XT is perpendicular to WY and YZ is perpendicular to WX. If you add these two, you get 180 degrees. That means a pair of opposite angles of the quadrilateral are supplementary. Hence the quadrilateral PZWPT, WZPT is cyclic. Okay, and here we are using the converse of cyclic quadrilateral theorem. Next part, we need to prove that points X, Z, T, Y are concyclic. Okay. Okay, so we need to prove that X, Z, T, Y, these 4 points are concyclic. That means they lie on a circle. Okay, so here we make an observation that angle XZY is equal to angle XTY. So here if you see the diagram, XZY is equal to angle XTY. Both are of measure 90 degrees, so they are equal angles. Okay, and XY is a straight line. Okay, and X and Y are the end points of the segment. From X, two angles are subtended, XZY, and xty. So two angles are subtended on the straight line xy, and both the angles are congruent also. So this is, here it satisfies the condition of 4 concyclic points. Okay, in the previous video, not in the previous video, before we started with 3.4, I have made a video, I have discussed about the condition that 4 points should satisfy for being concyclic. So here it's satisfying those conditions. Here we have a line, the 2 points joining line segment xy is the line segment joining the points x and y. From that we have 2 angles subtended, xzy and xty. So these 4 points are concyclic. These 2 angles subtended are on the same side of the line, and if they are congruent, then these 4 points are concyclic. Okay, so here in words, if you say precisely, if 2 points on a given line subtend equal angles at 2 distinct points which lie on the same side of the line, then the 4 are concyclic. Okay, the proof of this and this property we discussed in the previous video. That is the video before we started with practice set 3.4. The link I will mention in the description box, wherein we are discussing the condition for 4 points to be concyclic. Okay, please go through that video. Then this part is very simple. So these 2 angles are congruent and they are lying on the same side of the line xy. So these 4 points are concyclic. Okay, so to better understand this part, you should watch the video regarding 4 concyclic points, the condition that it should satisfy for being concyclic, for 4 points to be concyclic. So please refer the video. I will mention the link in the description box. Okay, so this is the 7th question, and there are 2 ways of solving it. This is similar to the question you saw in the solved examples, wherein you had to prove a property. They had just given the diagram and they had asked you to write the proof. I told you similar type of question we will solve in the exercise in detail, so that you can write the proof using this method. Okay, once you prove it, you can directly use that property. So there are 2 ways of solving it. So one way is I have wrote every step and elaborated just like the proof of the property, step by step, and then we get the answer. And another way is directly using the property. So both the methods we will discuss here. So first let's see the elaborative method. In the figure 3.60, a measure of arc NS is 125 degrees, measure of arc EF is 37 degrees. Find the measure of angle NMS. So here if you see this diagram, there is NMS. We need to find. So we need to find the measure of angle NMS, and here we have done a construction joining NF. Okay, then we will use inscribed angle theorem twice, and that is how the proof will, the sum will proceed. So angle NFS, if you see this NFS, this is an inscribed angle and its measure will be half of arc NS by inscribed angle theorem. That is the first step. So angle NFS is 62.5 degrees. Next, angle ENF, that is angle ENF, is inscribed angle. So it is half of arc EF. So it is half of 37 degrees, that is 18.5 degrees. Okay. Now if ENF is 18.5 degrees, then MNF is also 18.5 degrees. It is 2 different names for the same angle. Okay. Now here if you consider this triangle NMF, NFS is an exterior angle, and angle MNF and angle NMF, these 2 angles are the remote interior angles of the exterior angle NFS. So by exterior angle theorem, exterior angle NFS is equal to sum of remote interior angles, which are angle NMF and angle MNF. So next step, angle NMF will be angle NFS minus angle MNF, that is 62.5 degrees minus 18.5 degrees, which will be 44 degrees. Hence angle NMS is 44 degrees. So here if you observe, this angle NFS is indirectly half of measure arc NS, and angle MNF is half of measure arc EF. So if you write this property, then you will get angle NMF, that is this angle when you have 2 chords intersecting outside. So the angle between that 2 chords, that is angle NMF or angle NMS, is equal to half of arc NS minus half of arc EF. That is what indirectly we proved from this, and hence angle NMS is 44 degrees. Okay, so the proof of that property which is given in the solved example can be written in these steps. Okay, here you avoid these numbers, the rest steps will follow the same way. So once you prove the property, you can directly use the property also, and then you can find this sum in just 2-3 steps. You don't need to do this, but rather if you prefer this method of writing every step in the sum itself, that is also fine. So let's use the property directly and find the answer of this question. Okay, so here also you have two intersecting chords, but here the two chords are intersecting to the interior of the circle. So this property is also discussed in the solved example. You can directly use that property, or else I have showed you an elaborative method to do it. The property one also we will discuss after this. Okay, so this is another way of finding the answer. So let's read the question. In the figure 3.61, chords AC and DE intersect at point B. If angle ABE is 108 degrees and measure of arc AE is 95 degrees, find the measure of arc DC. So here the angle ABE is 108 degrees is given, and measure of arc AE, this particular small arc's measure is given to be 95 degrees. We need to find measure of arc DC. So first thing is angle ADE is half of measure of arc AE. This is by inscribed angle theorem. Okay, so here if you see this particular ADE, so AD is the construction made, the red dotted lines is constructed so that we can use the fact that ADE is inscribed angle and its measure will be half of AE. Okay, so it should be half of 95 degrees, which is 47.5 degrees. Next, angle ABD, that is this particular angle ABD plus angle ABE. So this is a straight line, so their sum, or the angles in linear pair, so their addition or their sum should be 180 degrees. So angle ABD will be 180 degree minus angle ABE. So ABE is 108, so ABD will be 180 minus 108, which is 72 degrees. Okay, now in this particular triangle ADB, which is to the left of the diagram, here you have that ABD is 72 degrees, ADB is 47.5 degrees. Now we need to, we can easily find the measure of angle DAB by angle addition property of a triangle, and that you will get to be, okay, 180 degree minus 119.5 degrees, that is 60.5 degree. Okay, so those are the two steps. Therefore, angle DAC, now if DAB is 60.5, then DAC is also 60.5 degrees. So angle DAC is equal to half of measure arc DC. So here if you see, this DAC is inscribed angle and in DC is the intercepted arc. So by inscribed angle theorem, angle DAC is half of arc DC. Now to find DC, DAC, you know, to find DC it will be twice of DAC, angle DAC. So 2 into 60.5, you will get the answer to be 121 degrees. Okay, so this gradually with this one construction and few steps, considering the triangle or the angle addition property or the extended angle property, anything you can use in this triangle and then find this angle. If you find this angle, you can find the measure of arc DC. Okay, other way around, if you are aware of the property, it's much easier. Let's see the okay, so here we are using the property. Now same question, here you have this angle ABE is given, AE is 95 degrees given. We need to find this arc DC. So here in the seventh question, the two chords were intersecting to the exterior of the circle. So there the property was difference between the half of difference between the two measure of the two arcs. But now the circle, the chord is intersecting to the interior, that means inside the circle. So here you take sum of the half the sum of measures of the arcs intercepted by the angle. So if two chords of a circle intersect each other in the interior of a circle, then the measure of the angle between them is the half the sum of measures of arcs intercepted by the angle and its opposite angle. So here if you see this ABE is intercepting AE and the angle opposite to it DBC is intercepting arc DC. So half of AE plus half of DC is equal to angle ABE and is equal to angle DBC. Since vertically opposite angles are equal, these two angles measure will be same, so that is fine. So angle ABE is equal to half measure arc AE plus half measure arc DC. Okay, now we need to find DC. Measure of arc AE is known and angle ABE is also known. So taking it to the other sides and then substitute the values. So half measure arc DC will be 108 degrees minus 47.5 degrees. Now AE is 95, so half of it will be 47.5 degrees. When you take the difference, you will get 60.5 degrees. Now half of measure of arc DC is 60.5. Then measure of arc DC should be twice 60.5, that is 121 degrees. Okay, so you use the property, still you get the same answer. You go by normal steps, then also you get the same answer. Okay, it's up to you. If you remember the property well, use it. It's much easier. Otherwise, you need to do the construction and to have to solve the question accordingly. Okay, so that's all with the practice at 3.4. Thank you for listening to me, guys. If you like the video, please share it with your friends and please subscribe the channel. You can also follow us on Instagram and please write any doubts or queries in the comment sections. You can also get to us through Insta. We will respond as soon as possible. Thank you.